So I'm going to move right on to the receiver side of the phaser radio, and there's kind of three basic parts to this. So down here we have the signal comes in from the antenna, passes through this low pass filter, which is primarily designed for the transmit side. But after passing through the low pass filter, comes up to here, and it's presented at pins 1 and 2 of the NE602 here. That's the RF input to those pins. There is also the RF signal generated by the SI5351 and the D-type flip-flops gets presented here at the oscillator pin of the NE602, and those two signals get mixed together. So this is a direct conversion style radio where the LO frequency is the same as the receive frequency that you want. So that mixed product coming out of here will be simply this frequency plus or minus this frequency here. And further, that frequency will be at the audio baseband. So this signal coming out of here will be the difference of the LO frequency and the RF frequency, and will be presented to this pair of op amps here for further amplification. So like I said earlier, there's no attempt here to suppress the unwanted sideband. You'll get both the upper and lower sideband coming out here as an audio signal, and as we build this up, I'll show that on the spectrum analyzer. Anyways, a simple pair of op amps here amplify the signal, and then it gets passed out through the audio jack, and then ultimately to the WSJTX software running on the computer. And the only other thing on the circuit to note here is this transistor here is turned on when the on transmitting, so it basically grounds this portion here whenever there's a transmit. You don't want sort of a signal leaking through here on transmit through to the audio out here. But there's no attempt to turn the NE602 off or the op amps off during transmit. You do have these clip diodes here, so basically this is connected to the output of the amplifier, and these two clipper diodes will clip any signals coming through here and will protect the NE602 from any of the transmit signals. Okay, so let's see where all this is on the board here. Obviously unpopulated at the moment, but here's the BNC jack on the input here. Here's the low pass filter right here. So there's the L5 and L6, two inductors on that, and we've got some associated capacitors there. And then the signal runs through down this path here, through this capacitor here, and then here's those two clipping diodes I mentioned. Passes through another inductor, all the way down here, and then here's the SA602 here. So there's pin 1 of the SA602. And then this is that op amp, the MC1458 op amp that's straight after the NE602 receive mixer. So I'll pull this all together, and then we'll inject some test signals here, and we'll see what's what. Okay, so here's the finished low pass filter section. The two toroids here, L5 and L6. Nothing special about winding the toroids. Direction doesn't matter. Conductivity does matter, and we'll check that later. But just double check the values of each of the capacitors. Obviously, they're critical. I've also installed the BNC. So to check that the toroids are correctly installed, I can check conductivity between the center pin of the antenna connector, the BNC, and all the way over here at C1. So that just confirms that you've taken the enamel off the wire correctly, and you've soldered the toroids in correctly. It doesn't confirm the value of the capacitors, of course, but Sometimes I go ahead and check that with a spectrum analyzer, but I won't do that in this case. I'll trust the designers have it right. So what we'll move on to next is installing the clipper diodes right here, and here. There's another inductor here, capacitor here, and then down at the bottom of the board is where we install the op amp right here. So what I'll do is I'll install all those components, and then we'll come back and do some testing. So just a quick update. The two clipping diodes have been installed up here together with this inductor, this capacitor, and then moving down to closer to the SA602. All the capacitors associated with it are installed. One little note, and it is covered in the errata in the manual, is this is actually C46, so it's a filter cap on pin 8, which is the power supply for the NE602. But other than that, no real tricky parts on the construction. Okay, so everything in the receive section, with the exception of this transistor that turns off the receive path or grounds the receive path on transmit enable. So I've installed everything else except for this here. So to test, so what I'll do is I've got my signal generator here set up to output a signal at 14074. So that should be the 0 beat signal. I shouldn't hear anything at 14074, but as I change that frequency, you'll hear a tone coming from the radio. I've got it at minus 50 dB, which is a very, very, very strong signal. You wouldn't get anything like that, but it's good to test that. And then just panning over to the circuit itself, just zoom back a bit. So this is the signal coming in from the signal generator. Obviously this is power, and then this is going off to my speakers. So this is the signal, the audio signal out that goes into the microphone on your computer connection. So let's play around with some frequencies on the signal generator. Let me pan up, make sure you can see that. Bear with. Okay, so let me tune up first. So you can see there, that's a 1 kilohertz tone that's coming out. All the way back down to 14074, which is the 0 beat. But notice as I tune down, I get the mirror of those I get the mirror of the audio there. As I mentioned before, this receiver component makes no attempt to differentiate between upper and lower sideband on receive. On transmit, of course, there's the whole phase shift network that gets rid of the unwanted sideband. But that basically confirms that the receiver path is all working, all the way from the low pass filter all the way through the NE602, through the MC1458 op amps, and then finally to the audio out. So what I might do as a follow-on video is actually get this on the air and see if we can see some FT8 activity. But that's to come. Okay, so it turns out I couldn't quite wait for the next video, so I thought I'd hook it up to my antenna. And that's this connection here, and that goes off to an end-fed half wave out in the backyard with about 60 odd feet of wire. And this is connected to my laptop. Obviously I'm powered up here, running WSJTX on my laptop, if I can get it all straightened up here. And as you can see, I'm receiving. So we're on the air, at least from a receiving perspective anyway. So there's the waterfall. Quite a few strong signals there. I did have to fiddle around a bit with the microphone volume on the laptop to get sort of that sweet spot. And there you can see a whole pile of received signals from all across the states there, and some indeed from outside the states. So that's quite good there. For those who are not familiar with WSJTX, the green ones are people calling CQ. So there's a CQ from Canada there, V3CCD. Now you can click on it here and it'll tell you how many, double click on it, tells you how many miles that particular person is away. You can't see that. So they're 1,260 miles away. And that's the beauty of this the FT8 protocol, is it doesn't require a lot of power to get a long way. So very pleased with that. Very strong signals coming through there, at least as good as that I've seen on my other radios. This is obviously peak. It's late in the afternoon. This is a peak time for 20 meters, so always a lot of activity at this time. But that's the receive section of the phaser complete. Obviously we're off to a shaky start, but it's looking good now. So anyway, I'll wrap this video for now, and in the next video we'll start to build up the transmit portion. Now, as I mentioned, I did blow that chip, so I do have to wait for the FST 3257s to come in. I ordered a few from DigiKey, so they should be here in the next week or so. But I can continue with the build up to the Talo, up to just before the Talo mixer. So anyway, that's to come in the next video.